Hey everybody, Mrs. Pasico here. Today we're going to learn a little bit more about the periodic table of elements. And what we're going to do, besides looking at just the box and understanding the number of protons, electrons, and neutrons in an atom, is we're going to learn how to draw an atom. Now, many of us already know that when we... Oh,
please come to the main office. Ms. Brodsky, the main office.
So when we draw an atom, it kind of looks like this, right? There's a center or a nucleus that has protons and neutrons in the middle. And then we either draw it where it kind of is crazy like this and the electrons are zooming all around, or sometimes we draw it where we have the nucleus and then we draw circles around it, right? Those are the different ways that we draw an atom. What we're going to focus on today is actually not just drawing a picture, but an accurate model of what we call a Bohr model. Sounds boring, doesn't it? Bohr model is actually named after the guy that came up with it, and it's anything but. It's super not boring. It's actually a lot of fun. So here he is. There's Mr. Bohr right there. And we're going to learn how to make a Bohr model today using the periodic table and using our knowledge of atoms. Okay, here we go. So a Bohr model basically looks like this, right? If you look at the top part of the screen here, you'll notice that this is the picture of an atom, right? We've got neutrons and protons in the middle and the electrons are zooming around the outside, right? What we're really going to create is look at the periodic table and say, oh, an atom of carbon, and we're going to draw something that ends up looking like this. So we're going to have the protons and the neutrons in the center and the electrons drawn in kind of a systematic way on the outside. So we're going to learn how to do that today, and it's actually really fun. So if you enjoyed using the periodic table, especially finding protons, neutrons, and electrons, here's another way to add a little drawing to it. Okay, so you might be wondering, why the heck do we have to know how to do this? Well, as we know, atoms combine to make a lot of stuff, right? We don't just have a bunch of carbon atoms hanging out. We're made of a bunch of different things, right? Things that combine. And one of the ways that atoms combine is through these electrons, and they can either share them or take them or give them away. And so understanding what the electron configuration, what we call an electron configuration, and understanding what it looks like on the outside will help us learn and understand chemistry into 7th grade, into 8th grade, because eventually we're going to talk about how atoms come together and make something. So this is an example of 2 hydrogen atoms, which each have 1 electron. You can see the blue combining within an atom of oxygen. And that makes kind of this Mickey Mouse drawing here makes H2O. And atoms are able to combine through their electrons. So these diagrams, these Bohr models, help us understand how they might combine and maybe what they can combine with and what they cannot combine with. Okay, so let's try a little practice. You're going to need 2 tools today. You're going to need the periodic table link. Well, actually, I'll just show you. So if you click on it, it goes right to the periodic table that we've been using, right? And then this is just the reminder of how to use the atomic symbols in the box, right? If we remember when we look in the box, that's the atom, right? So C stands for carbon. The top number is what we call the atomic number, and that's always the number of protons and electrons. So carbon has 6 protons, 6 electrons. And then what we sometimes refer to as the atomic weight or the atomic mass or the mass number, right? This is the amount that includes the protons plus the neutrons. So if I wanted to find out neutrons in an atom, I'd take 12 minus 6, so bottom number minus 6, and I'd get 6 neutrons. So an atom of carbon has 6 protons, 6 neutrons, and 6 electrons. So if you remember, we did that before break, right? So today what we're going to do is we're going to look at how to draw a couple of examples. So let's look at oxygen. Okay, so we always start, we're in the center, we make a circle. This is to represent the nucleus, right? And if you remember, inside the nucleus, the absolute heaviest part of the atom, right, where the most mass exists, there are protons and neutrons. So we write a P and an N here to stand for the protons and neutrons that must be in this middle part, okay? And then to draw the electrons in a way that we understand is we make these rings. These are rings, or what we call energy levels, that basically these electrons go on. And sometimes you might have a couple rings. Sometimes you could have hundreds of rings if it's one of those crazy atoms that's all the way down here and has a ton of electrons, okay? But we're just going to practice. We're going to practice with just oxygen, okay? And the simplest thing to do is to first look at the example of oxygen. So I'm going to go down, Mine doesn't really let me do that very well, does it? Okay. So I'm going to go down here, and what I'm going to use, and I know it's hard to see, so let's see. What I'm going to use is I first have to figure out how many protons, electrons, and neutrons in oxygen. So the first thing I'm going to start off with is look at my periodic table. So I'm going to go to where oxygen is, whoop, and I'm going to notice that there's an 8 on top and a 16 on the bottom, okay? And if I remember from before break, the 8 on top is the atomic number. So if you can see this, hopefully you can see this. You might not be able to see it, but the atomic number is 8. So I'm going to write it down here just to remind myself, okay? If you remember the atomic number is 8, the top number, that's always the same number of what? Protons and electrons. So I know that I have 8 protons, and I'm going to type that in. Whoops, make that a little bigger. I'm going to type that into the screen right now. So there are 8 protons in oxygen, okay? And if you remember, and we're going to keep this in our brain, there are 8 electrons, right? Because protons always equals the same number of electrons. So 1, 2, 3, 4, 5, 6, 7, 8. I have 8 electrons on the side, and I'll show you how to place those in a second, okay? So if I'm doing pen, I'm going to write that there are 8 protons and 8 electrons. Hopefully you can see that kind of on my screen. And then the mass number is the bottom number, right? So if we go back, we look at the bottom number is 16. So the mass number is 16, okay? But if you remember, what I have to do with that number is take the bottom number minus the top to get my neutrons. So to figure that out, I have to take 16 minus 8. So 16 minus 8 is 8. So my neutrons are 8. Okay, so if you remember, that's what we did before the break, right? So now I'm going to write 8 in for my neutrons, and I'll make that a little bigger. 8 for my neutrons, okay? So now what I have to do is slide over my electrons. And how this always works, and this is just a rule, in the very first ring outside the nucleus, there can only exist 2 electrons. So I'm going to start and I'm going to count. I notice I have 8 electrons and I have to use all of them. So here's what I'm going to do. And look at where I place them. So I'm going to drag this one over and go 1, 2. See how I place that? That's all that can go in the first level. So if my atom happened to have 2 electrons, this is what it would look like. And it would just look like this, okay? But mine has 8 electrons. So now I have to place the other ones. And here's what I do. I bring them and I can have 8 in all the other levels. So 2 in the first level, only 8 in all the other levels. So here's what I'm going to do. I'm going to go, so I've already had 2. So 1, 2, I'm going to go 3, 4, and I put them together like little twins here up top. 5, 6, and I put them on the side just like a clock, right? 7, 8. Okay, and that's what my completed oxygen model would look like. That's a Bohr model of oxygen. So I know that it has 8 protons, 8 neutrons, and a total of 8 electrons with 2 rings around it. And I can ignore that last other ring. I wouldn't have to draw it. Okay, we just put it in there so you'd have another ring to use if you need it, right? Now, what would happen if oxygen had more electrons? Well, let's say I had more electrons. Let's say that we found another atom that ended up having 3 more electrons. Okay, so what I'd have to do then is I'd keep adding to the circle. So there were 8 here. So now I'm going to go 9, 10, and whoops, let's put those closer together. Notice how on the second ring I have 2 here, 2 here, 2 here, and 2 here. And I just keep adding them. So I can only have 8. So if I have an extra electron left and I have more to add, I'm going to go ahead and put it in the third level. And I'm going to keep doing that until I use up all of my electrons. So that's what it would look like, okay? But I'm going to get rid of this for now because we didn't have that many in oxygen. And that's how I do oxygen. Let's try one more, okay? Let's go ahead and try carbon. First thing I want to do is find carbon on my periodic table. So I'm going to go to my periodic table and I'm going to notice, okay, carbon has a top number of 6 and a bottom number of 12. So if I'm figuring that out, I know that there are 6 protons and 6 electrons. And then to find neutrons, I would do 12 minus 6. So I'd have 6 of all of them. Yikes, 3 sixes, right? So I'm going to reflect that in my circle. So I'm going to go back and I'm going to type in that there's 6 protons. Make that bigger. And 6 electrons and 6 neutrons. So now I have to take the 6 electrons and put them around in rings. Okay, if you remember how many go in that first ring, only 2. And they have to look like this. So I'm going to go dot, dot. Okay, that's 2. I still have to get 4 more, right? So now I'm going to start to fill up the second shell or the second ring. So I've already had 1, 2, 3, 4, 5, 6. And even though there's extra electrons on the side, I'm going to ignore that. This is what my carbon model, my Bohr model looks like, 6. So it has 6 protons, 6 neutrons, 6 electrons with 2 on the inside, first ring, and 4 on the second ring. And then the third ring, again, we have there if you need it, but this really only has 2 electron rings or 2 electron levels. Okay?